talking about moderation, you guys know moderation. So we're in essence interested in understanding how results vary for different groups of people. So we might have some variable here, and we're saying, all right, this is some group membership variable. How does being a member of this group or not affect this relationship? So in other words, this path might be stronger for one group and less strong for another group. And that's typically how we would draw a moderation model. Especially in a structural equation modeling framework, we're often interested in how we would represent these things visually, and that is how you would represent this visually. However, have any of you tried to draw something like this in Onyx? It doesn't go so well. You can't do that. So although this is how we would represent it, maybe even in a figure, this is not how we would actually conduct the analysis. And this is true whether we're just talking about good old regression or something like structural equation modeling. So how do we test this statistically? You guys have done this before. How do you typically test moderation? Anybody?
Create an interaction.
You create an interaction. And what is an interaction? It's literally the product. You take two variables and you multiply them and you make a new variable that is the product of those two. So if you were actually going to do that model in Onyx, this is actually what you would draw, even though it's represented by that other figure. So you've got the main effect, and then you've got the interaction, the product of those other two variables, and it has its own path. Now, if you were doing this in Onyx, truth be told, you would probably correlate those predictors, especially because they're interactions. You expect an interaction and its main effect to be correlated. And this will answer a number of basic moderation questions. Yes? Should the interaction term and the predictors? Yeah, that's what I was saying.
Okay.
So you'd probably want, if you were actually doing this, you'd probably want to correlate x2 in the interaction, x1 in the interaction. And if you thought or had reason to believe x1 and x2 were correlated, you might very well include that correlation. Although then you would have 0 degrees of freedom. That's okay. But then essentially it's a straight up structural regression, no degrees of freedom, saturated model kind of thing. So there's nothing wrong with running this model. It's just going to answer basic research questions. So let me just flash back one here. So this is how you would represent it if you were talking to somebody about what it is that you were doing. But this is how you would actually test it in the software. Is everyone with me so far? Are there any questions? Yes?
So when creating that interaction term, would you have to create it in SPSS and then upload the data set, or is there a way you can create it in Onyx?
In Onyx, you have to do it external to it, as far as I know anyway.
Okay.
If you're using M+, there is a way to calculate variables based on other variables, but I have to tell you, I have a hard time getting it to do what I want it to do. Joanna thinks that's sad. I think it's sad too. I don't know if it's a sad statement about my skills, but it's certainly sad. That define command, I have a real hard time with it. Do you? some
Not
lunch.
that I can think of, but maybe.
But if you're using M+, you can calculate it in the software. But in Onyx, you cannot. You have to do it in SPSS. Yes?
So, in the previous slide, that you would want us to report it like this, where, or, no?
You might want to report it like this. This is how you would represent it, though.
Yeah.
It may be that you don't represent it that way in your figure, but this is good.
So, we would not include the interaction, term in here?
No.
Or the path?
This is the confusing thing, is that it's embedded in this arrow.
Okay.
So
But would we have to manipulate somehow, or do some kind of calculation from our,
well, this
from
is
the Onyx to get it to
this is why you might not show it this way, even though this is how you would often represent it. You're saying, I expect this variable to affect the relationship between these two. That's how you show it, but that's not how you do it.
Yeah.
So I don't have a good answer for you. Okay. Any other questions? Yes?
Can you explain again why it's only basic moderation questions that can be answered?
Oh, that question is a great question, but it's going to answer itself as we play out here.
Okay.
Because I'm going to show you what else you can do and why this is limited. Yes, we will get there, I promise. Anything else before we move on? Okay, so this should line up with everything that you currently think about when it comes to moderation and testing moderation through interactions. This is just saying, yes, that's fine. But as you'll see, there are other questions that can be asked, other questions that have to do with group differences that get at moderation in some ways. And we can talk about those. So there are these limitations to those manifest interaction terms. What I mean is you calculate the interaction and you put it in your model. There are limitations. Going right up to your question. So there are lots of different ways that groups can be different other than just that simple one path kind of thing. And this is particularly true when you're running complex models. So think about a model like this. What are your interactions? What are you going to do? Multiply this by that other variable, like intervention status? Because you can imagine each one of these associations could be different. It could be that the stability paths are different for the two groups. It could be that these cross-lag paths are different. And then not only then, but you've got the cross-lag paths over time, the stability paths over time. Good luck figuring out how to do that with interaction terms. Very, very hard. And, shall we say, dissatisfying. And it's not that it's impossible, but what if you've got latent variables? Latent variables aren't in your data set to calculate the interaction terms with. So then you might have to output factor scores to calculate the interaction, blah, blah, blah. That gets, again, very messy. And even then, I don't know exactly how you would put those in. So when you get these complex multivariate models where lots of things are being estimated simultaneously, those interaction terms reveal themselves as limited pretty quickly. Other comments or questions? You see what I'm saying? So think about a relatively simple model like a CFA. And even with this very simple model, there are a lot of ways that the two groups could be different. So you've got a factor, and you've got 4 manifest variables with some residuals and some factor loadings. And it turns out like each one of those things can be different. So first and foremost, we're going to be interested in the measurement weights here, the factor loadings. Because what if the factor structure looks different for the two groups? So for example, think about something like differences in how depression manifests itself amongst men and women. I'm not saying that there are differences, but it's plausible to imagine, oh, men manifest depression with a lot of this variable and kind of less of these, whereas women manifest depression with a lot of this variable and less of those. So in that case, you're testing to see, do the factor loadings differ across two groups? You can imagine that an intervention even could shift the factor structure to be more one thing than the other. It could be that there are racial, ethnic groups differences between the way that a particular latent construct has manifested itself. And we're just beginning. That's just the first way that things could be different. Now, that first way that things could be different is also one of the most interesting ones. But if you show that this factor is different between the two groups, you kind of should stop there in many respects. Because now you're measuring two different things if you let them be estimated differently. That's a little bit of a digression. But you'll notice how that first question right out of the gates is one of the most important if you have some sort of factor model. You can also have means be different. So you can have the factor structure be the same, but have the means on those variables be different. You could even kind of roll that up into differences in the factor means. So things can be different in terms of means. So it's the same structure, but these two groups still differ on their levels. Well, that kind of makes sense. And you can even talk about differences in the error structure. So it could be that this factor better captures the variance in this one group versus the other group. Even if it's measured the same in terms of factor loadings, it could be that this factor is a better representation and therefore has less error for one group over the other. Yes?
When you say there could be different means, is that represented on
Not so
here?
much.
Okay.
I do have it in a later one, but we need that triangle in there.
Oh, yeah.
Yep. Good point. Any questions here? It only gets more complex, so if you have questions, do ask them as we go. Think about a growth model. Now we've even gotten more ways that the groups could be different. So you could have it where the two groups grow at different rates.